Dear colleagues and friends, welcome to the world of plasma technologies. We would like to tell you about different processes which are united under focusing on dramatic improvement of reliability as well as service life of the machine's part and components, improve of their features, reduction of service costs. These are modern plasma technologies for supersonic deposition of protected coating and surface engineering with use of combustion materials from hydrocarbon gases burning in air. Their effectiveness is proved with many years of commercial use under the new requirements from the industry and is focused on large-scale production.
The new approach to building the supersonic plasma powder spraying equipment has been developed in view of the current trends. The approach is based on using a variable composition mixture of gas and air and a stabilized elongated electric arc that burns in a plasmatron and is adapted to meet the technology requirements. The company currently manufactures plasma and auxiliary equipment, provides its commissioning at the customers, transfers a set of typical technologies and know-how, and develops specialized technologies for the deposition of coatings using its own equipment. The plasma equipment consists of a standard set of components such as power supply, plasmatron, powder feeder, control panel, and service line.
I remember.
Aluminum-ceramic coating is designed for corrosion protection of ferrous metal structures that operate in weak and strong corrosive environments. These are ship bodies, sea oil platforms, and pipelines. The composite coating comprises aluminum matrix with homogeneously distributed and metallurgically coupled ceramic particles. Therein has low porosity of 0.5% and is well adhered to the substrate. Its tensile strength is 35 MPa. The coating is produced by high-energy plasma spraying. It is characterized by high resistance to attack by corrosive media and salt solutions. Under the effect of main operating agent factors such as temperature, the joint action of temperature and moisture, corrosive media, and electric potential, the aluminum-ceramic coating does not change its initial properties and plays a protective role. The coating resists a temperature of about 450 centigrade. Being deposited on the weld, the coating does not only protect a weld against corrosion, but also imparts to the weldment the high resistance to corrosion fatigue cracks initiation, including cracks initiating in the fusion zone under repeated static loading. The aluminum-ceramic coating protects also the regions having a partly peeled coating. The aluminum-ceramic coating does not require further impregnation and is superior to the aluminum one in corrosion and wear resistance. Steel sheets with the coating are prone to cold forming and rolling without worsening of their coating protective properties. Developed is the technology and specialized equipment based on the supersonic arc spraying gun, where the supersonic jet of combustion products of hydrocarbon gas with air are used as a spraying gas. New possibilities for satisfying the special requirements to coatings on parts are opened by high-speed wire spraying. This is provided due to raising the kinetic energy of particles under spraying, increase of their concentration in metal flows, lowering of the spread of parameters such as velocity, temperature, and sizes in the vicinity of the substrate. This determines increase of adhesive and cohesive strength of coatings, decrease of oxidization, and improvement of stability and reproducibility of their properties. The supersonic electric arc metallization machine Plazma can be applied in all typical cases where it is necessary to deposit high-quality coating. This allows the heavy-duty parts such as shaft, crankshafts, brake drums, etc. to be efficiently repaired without any degradation of fatigue strength. The service life of repaired parts is not inferior to that of the new one. A new installation was successfully tested in the industry to repair worn-out motor components and deposit corrosion protection coating. for plasma hardening of railway wheels, characterized by low capital costs. The process is commercially applied at railroads of Ukraine, Latvia and Moldova. The hardening technology is cost-effective and will result in 5 to 1 return on investment. The technology consists in processing a working surface of a wheel flange by the concentrated heat source, plasma of the combustion products of air with hydrocarbon gas. The product of the technology is the wheel with the increased resistance to contact, fatigue failure and increased life. The technology has following benefits. Local, within the zone of the highest wear surface hardening of the wheel flange to a depth of 3 mm and width of 30 mm. This provides the optimal matching of hardnesses of the contact surfaces of both wheel and rail. Structure modification of the hardened zone, it becomes finely dispersed. This leads to improvement of all mechanical properties, including decrease of friction factor in contact between the flange and lateral surface of the rail head and increase of crack resistance of the wheel material.